Hello, 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 and welcome back to Mr. Marlowe's 6th grade online math class. Today we're going to be working on lesson 20, which is solving one-step equations involving decimals and fractions. My target today is I can solve one-step equations using algebraic methods, which involve decimals and fractions. My second target is I can check to determine if their solutions make the equations true. Okay, so this is pretty much what we've been doing, not pretty much, this is exactly what we've been doing the last few days. Only now we're going to be using numbers that have decimals and or are fractions. Okay, so let's take a look at example 1. Solve 3.5z is equal to 45.5 algebraically, then check your answer using substitution. Okay, so my first step, just like before, is I'm going to copy down the question. So 3.5z is equal to 45.5. Now remember, if I have a variable next to a number, what we call a coefficient, this means 3.5 times z, or 3.5 multiplied by z, is equal to 45. And if I'm solving an equation algebraically, it means I want to isolate that z, that variable, to find its worth. Okay, and the way I do that is I perform the inverse operation of what's shown here. So since this is 3.5 multiplied by z, the inverse operation would be division. So I'm going to divide both sides by 3.5. Now I'm showing it like this because remember, fractions are the same thing. They can be read as division problems. So this is 3.5z divided by 3.5, right? So 3.5 divided by 3.5. What's that? Well, any number divided by itself is 1. So I'm just left with 1z. Okay, on the right, I have 45.5 divided by 3.5. So that's going to take a little bit of work. So 45.5 divided by 3.5. Okay, now remember, if I'm dividing decimals, I don't want a decimal out here. So what I'm going to do is I'm going to move that decimal point 1 to the right. Okay, and if I move that decimal point 1 to the right, now I have 35. But if I move that decimal point to the right, I also have to move this decimal point to the right. Okay, so I have 455 divided by 35. So I'm going to rewrite that. 455 divided by 35. Well, let's see, 135. 35. Right, and then I get 0, 1, 35 can't go in there, so I drop down to 5, right? 35 goes into 105 3 times, okay? And 0, so my answer is 13. Z is equal to 13. Now if I want to check, okay, I'm going to take that result that I got, z equals 13. I'm going to go back to my original question, and everywhere I see a z, I'm going to plug in 13. So let's do that and check and see if we got the right answer. So 3.5 times 13 is equal to 45.5. All right, well, let's check and see if that's true. 3.5 times 13, let's 9, 10, 35, and I get 5, 5, 4. I have 1 decimal point, so 45.5, right? And if I rewrite this, I get 45.5 is equal to 45.5. Is that true? Sure is. So I know that 13 is indeed my answer. Okay? Example number 2. Solve b plus 92.7 equals 105.4 algebraically. Then check your answer using substitution. Okay, so this one we have an addition problem. So again, I'm going to start by writing down the question. Now, I want to isolate the variable, which in this case is b. B is 92.7 is being added to b, so I need to perform the inverse operation, which is subtraction. So I'm going to subtract both sides by 92.7. Okay. 92.7 minus 92.7, well, that's just 0. And over on the left here, well, I have, let's see, 4 minus 7, I can't do that, so I'm going to borrow. And 0 minus 9, I can't do that, so I'm going to borrow again. And I got 1, right? So, I should have lined these better. I should have lined these up better, Mr. Marlowe. But my answer is 12.7, okay? So now we're going to use substitution to check our answer, okay? So I'm going to write this a little bit clearer. B plus 0 is B, and then we got the 12.7 over here, okay? So now I'm going to use substitution to check my answer. I'm going to go back to the original, and everywhere I see a B, I'm going to put a 12.7. And it's 12.7 plus 92.7. And we want to know, does that equal 105.4? Well, let's test it out. I got 12.7, 92.7, got 4, 1, 5, 10. Line up those decimal spots. So I got 105.4. Is that equal to 105.4? It sure is. So we know that 12.7 is indeed our answer. All right, let's take a look at one more. This is a fun one. Solve 3/4 y, or 3/4 times y, is equal to 8/5. Algebraically, then check. So I have 3/4 times y. We want to know, is that equal to 8/5? So what we can do is, this is 3/4 times y. So we want to perform the inverse operation, so we can isolate that variable y. So now if I have 3/4 times a number, then divided by 3/4, well, that's just going to cancel out, and we're just going to be left with y on the left side of the equation. Now we have 8/5 divided by 3/4. Well, we're dividing fractions, so we can do keep, change, flip. We're going to keep that 8/5. We're going to change the division to multiplication, and we're going to flip the 3/4 to 4/3. And then when we multiply fractions, we multiply across. So 8 times 4 is 32. And 5 times 3 is 15. So y is going to be equal to 32/15. Okay, now here's a good one. So how are we going to check this? Well, we would check it just like anything else. I'm going to take this 32/15 and I plug it in wherever I see a y. So I'm going to go back to my original question. 3/4 y is equal to 8/5. I'm going to plug in my answer. And 3 times 32 is 96. Okay. 4 times 15 is 60. Is that equal to 8/5? Well, what do you think? Can we reduce these two, can we reduce that fraction at all? Well, let's see. I know that let's pick a number. I think 12 goes into both 96 and 60. Okay, so 96 divided by 12 is 8. 60 divided by 12 is 5. Is 8 over 5 equal to 8 over 5? It sure is. So we know that that is indeed our answer. All right, that's it for today. Hope you enjoyed the video. If you have any questions, reach out to me on Remind, email, or during my office hours. Again, today was lesson 20, solving one-step equations involving decimals and fractions. Our target was I can solve one-step equations using algebraic methods, which involve decimals and fractions, and I can check to determine if their solutions make the equation true. All right, guys, have a great day, and I'll talk to you soon.